Okay, so safety, ethics, and experimental study design. I will do in a different order, but this was the title. So I think AI has changed the way we detect and track humans and human motions in experiments. This is the first observation that it's very easy for me to say. So I was taking some examples from my very old studies now, 2012, 2013. We were doing experiments already with humans interacting with humanoid robots, like in this case, and we were using traditional tools from computer vision, like 3D people tracking, face streaming, face pose estimation, gaze, hands. We were tracking everything, but let's say with traditional tools that now people don't even know because they're outdated, no? Okay, because now you have a nice model that you can take, tick, 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 tick. And so all these models now, they can track the human people from, I mean, just a camera, and you launch the models. You can extract the skeleton, and I mean, they work very well. They do the segmentation, so we have these models now, we can really use them. AI has also changed the way we process human commands in natural language in experiments. So this is an experiment that we did like 2013, 14, then it was published later. So it was an experiment where people were telling the robot teaching how to assemble an object. So it was really like, now we could say it's a sequence where you have an AI that is reasoning, do this step and then this step is accepted. Back then we were doing the experiments with the robot, and we had the speech, a module for speech detection, but it was based on keywords detection. So we could only catch few keywords in the natural speech, in the natural sentence. And so this was not robust enough, because people, when people speak to the robot, they speak in the natural way. So you cannot predict exactly if they will say that keyword that you are expecting. Even if the keyword is stop, they will say stop in 20 different ways, and they will use something that you didn't talk about. So, but at the end, I mean, in the experiments, they were really comfortable. But to be able to carry out the experiment, we needed to do it in a Wizard of Odds. So there is an operator that is piloting the robot, because we couldn't do it in this way. And now, I mean, you saw the presentation of Denise yesterday. Now we can give the commands to the robot, because there is whisper, and then there is a LLM, VLM, etc. So we have the capacity to now finally speak, say something, and then process, and then let the robot do the task. So this is also changed. And I think we saw Rudy's. I mean, the next step at some point, this VLA will also include humans. So far, we see a lot of benchmark and task where the robot is moving stuff in a mini kitchen, and we see a lot of manipulation, but at some point we will have humans appearing in front of these robots. I mean, there are some cases of navigations, VLA for navigation, where you can see humans, but there are still obstacles. They're not yet humans interacting with the robot. But at some point this will arrive. Because now, I mean, we have the recipe. Once we have the recipe, then the recipe will be extended to more complex cases. But at the end, this is super great, but these are just tools. So tools like the other. If in 10 years we have a new technique, we will use a new technique. And so if humans are part of the game, at the end, we cannot ignore the fact that the humans are the final end users of the technology. And they have to approve what we do. It's not just a competition to be like a 0%, 0.1% better in a score or a benchmark. At the end, the human has to say, yes, I use this. And then we'll be successful. So if we want the humans to validate, we need to start getting used to do experiments where humans are validating what we produce. And to do this, first we need to start learning how to ask the right questions, because this is not just about performance on a benchmark. It's like asking the right question of what makes the difference for the human to say, yes, I use this or no. And then designing good experimental protocols where we test the AI technologies or the controllers or whatever in the good way, ensuring safety, compliance, compliance to ethics, compliance to all the laws and the rules that are coming every day. Okay, so experimental studies with humans and AI. Bear with me, there are not so many images and videos, but I know that this will be boring. I will try to be quick, but I will give you the slides. I will not detail all the things I wrote. You will have the slides so you can use them as a sort of manual, okay? So first, when we design experiments, we have to think about the scientific process. Scientific process is always like I make an observation, I ask a question, I formulate a question, I formulate an hypothesis, and then based on my question and my hypothesis, I design an experiment, I run my experiment, I measure the data, I study, analyze the data, I interpret, and then these validate my hypothesis, validate my theory, and if yes or no, this will give me the input to ask a new question. And then this goes on and on and on. It's very close to the data flywheel, if you want, because the data flywheel is the same. You take data, you have a model, you test, and then you say, okay, I get more data, or etc. The circle is the same. But this is older, like starts from Galileo, from the Greeks and the Egyptians. I mean, we all do experiments and the same way. Okay, so now that we have this in mind, what do we have to do when we think about constructing an experiment? Like we have to build the protocol and ask the right question, identify all the things. These are items that you can use when you write papers as well. Because when you do an ethics protocol application, usually the ethics committee asks you to detail all these elements. And these are the elements that you write typically in the method sections of your paper. So basically, you are writing the paper to your ethics committee without the data, the data of your experiment. So first, we have to identify well what is the research question. Is it an open question? Because sometimes you say, I don't know, I want to observe what happens, like what happens in our robots if he's serving coffee in the cafeteria. I don't know, I've never done that, so I have no data to formulate an hypothesis right now. So, I mean, I can read the literature, but I never did an experiment like this. So, I don't know, for me, like now we're a bit in the open area. But maybe, I don't know, Rudy already did an experiment with his VLA. He created some tokenization, and then he says, okay, now I want to change this because I figure out that this tokenization is too long, and then I want to shorten it, okay? And he makes a new experiment. So first it's the most important job of a researcher is to ask the right question, to be able to formulate the right question, because maybe at the end it's a bit cloudy in your mind, but you know, working together with your colleagues or friends, supervisor, etc., then the question is refined and then it's really good. Okay, reading the literature, this is important, but sometimes you have to really learn how to ask the right question. And then you formulate a theory and hypothesis. So this is important because this step is the one that identifies what are the variables that you use. So these are the variables that will end up in your plots, in your tables. How you measure them, and how you measure, this is, okay. And so there are two types of variables, independent variables and dependent. The dependent are depending on the independent. And then there are some hidden variables that we'll see later about the confounds and other things. So when you identify the variables, it is very useful that you are able to formulate a sentence in terms of hypothesis with these variables, because then this is the sentence that allows you to read the plot and everything will be clear. If this sentence with hypothesis is not clear, your plots will show stuff, but then we don't do a correct interpretation. Conditions. So these are the conditions of your experiment. For example, if I do an experiment with some algorithms and I want to try flower VLA 1, flower VLA 2, beast, pi 0, etc., these are your conditions, okay? Because you change something in the condition. But in the case of robotics, you can say, for example, I don't know, I have the robot serving coffee. In one case, I use an AI model that is generating the end-over gesture, and in another case, I don't do it. So this is also, and you can have also conditions in the scenario, for example, if you inform the participants or not about some conditions. Participants, this is very important. You have to identify who are your participants. And this is important because most of the time in papers, we see the papers, so we say we do a pilot study, the easiest is to ask our colleagues, right? So you go in your lab, in your team, or the other team next door, and you ask all the students can you please try my experiment, etc. This is okay, it's not a bad thing, because if we are doing a preliminary experiment, etc., or we're designing a new robotic skills, it's totally fine, okay? This is very easy to say. When people report correctly the participants, you see the average age. The average age is around 22, 23, 25. These are students, okay? If the average age is 40, this means that they got somebody in the administration maybe or somewhere else. And then usually this is good, but we cannot really claim that our system can be deployed and it works. Because if these are participants, like students from the university, they are kind of biased. Maybe they don't know anything about your experiments, but these are young students, so they don't generalize to the granny next door, okay? So it's good because in papers we do, and there are many reasons for doing it, but don't overclaim, oh, we have now solved whatever it is, okay? No. Okay, and so of course, if we do the studies with frail people, children, elderly, these are particular participants. So the ethics committee will ask, for example, to have, in the case of a minor, you need the parents. In the case of the elderly, often you need a doctor, or a geriatrist that is present in the experiments. Adults are from 18 to 64. 64, 65, depending on the rules, okay? And most of the time, it's better to ensure that people are in good health when you do the experiments. Then, of course, if it is judging if the robot is serving coffee in a good or bad way, we don't care if they have, asthma. But if you are doing an experiment with exoskeleton, maybe yes. Like I'm asthmatic, I cannot be a good subject because I will bias the data. Okay, and then also one important thing is when you construct your protocol, there is a lot of sources of bias. In the case of the participant, it's the sample selection bias. For example, if you ask only the people in your team, this is biased. If you don't balance the participants in terms of gender, age, etc., this is also a source of bias. So it's better in the papers to declare, because sometimes if you are like in our building, the percentage of girls is very low, because usually in computer science and robotics we don't have a lot of girls. We have here, I'm very happy. When I was doing the PhD, we were even a smaller percentage. So now for me this is huge. So I'm really happy. But I mean, at the time, when I was doing the PhD, I was the only girl in the lab. In the postdoc in Darmstadt, I was the only one, again for a time. So if I was doing the experiment there, I would only have men. Okay, but if you want to do an experiment that claims something, then pay attention in having a good population. Assignment method. So this is when you ask people to do the experiment and to cover all the conditions. Sometimes so there are two main methods. There is a third, there is the hybrid or mixed design, but the main are between subject and within subject. This is the name. So in between subject, each unit, so each participant is doing only one condition. This is the ideal case, because then you're sure that there is no conflict, no bias arriving from the fact that they do all the conditions. But this requires a lot of participants. So usually we do within subject, so which means that all the participants do all the conditions, but we have to randomize the order to remove any possible source of bias. So this makes the experiments longer for the participants. So sometimes you can do it, sometimes no. Okay, again, variables. This is important. So you have so the variables that are related and the metrics that are related to the entire experiment. Sometimes you can use stimuli, which are events that trigger a particular behavior, a particular condition. You have also covariates. So the covariates are particular variables that you cannot control, you cannot manipulate. And so sometimes this happens. This also has to be declared in the paper. And then you have confounds. Confounds, these are variables that are actually the variables that determine the behavior of the dependent variable. These are sometimes very difficult to find. And that is why you randomize, you control the population, you control all the conditions. If you find this is a particular cause of sometimes paper rejection, because the reviewers say, oh, but you didn't realize that you only do the experiments with, I don't know, there is a mega bias, mega confound in your population, and so all your results are invalidated for a reason. Measure and metrics, so this strongly depends on the type of experiments that you do. If you do experiments with many models, you will have a lot of measure and metrics related to the models, like the size, the tokens, the description of the tokens. But if you do experiments with humans, so you have also human-related measures. You have error, task performances, and so on. You can have physiological measures, so you put a lot of sensors on your participants. Behavioral measure, like for example gaze, particular gestures that they want to do, speech, whole body movements. Usually we also do a lot of questionnaires when you do experiments with humans, because sometimes you want to have, like for example, so first there exists a lot of standardized questionnaires from the psychology literature or the neuroscience, and these are standardized questionnaires that have been tested by the psychologists with I don't know, thousands of participants, and so they are normalized, and so you have scales and tools to code the results of a questionnaire and give a score that gives you an important information about the participants. For example, personality questionnaires to identify if a person has, I don't know, neuroticist behavior or very introvert or extrovert behavior. These are a standardized questionnaires that exist. And so the easiest is to talk to a psychologist that usually knows them a lot and can identify the good questionnaire for you to examine a particular thing. You don't have to disregard this, or this is like human science, I don't care because I do... No, because I mean the way people behave and interact with AI is strongly impacted by the personality factors. There are a lot of papers from Facebook from the last decade, actually, when they started to, I don't know if you remember, maybe you were too young and you didn't have Facebook, but when Facebook started, sometimes they were asking questions about your personality, your attitude. There were hidden questions that sometimes you could do. And some years later, they came out with a series of papers where actually they were able to predict the likes and the behavior of people interacting in the social media depending on their personality profile. So they were constructing actually a profile of yourself, age, personality, and they were very, very accurate in estimating your personality profiles, which says a lot about how they can take the data and manipulate, because this is an information that, since it is used to predict your behavior, like a word model, in a sense, they are able to exploit that and manipulate the way you receive the information, the way you access the information. So yes, now I close this parenthesis, but when I teach, I have a lot of papers that I can send you that I found, and these are very, very, very interesting. This will change because now that we can speak to the robot, it's not just typing on a shell. It's really speaking. And when you speak to a robot, in your mind, there is something that is evoking the fact of speaking with another human. And so all your personality, all your behavior, all your characteristics appear in the way you express and interact with the robot. So we have to be, aware of those. Okay, close again the parentheses. Questionnaires. So sometimes we design ad hoc questionnaire to ask, for example, to evaluate our system. There is a way to design questionnaire and to ask questions, because even in the way people answer to questions, there are a lot of sources of biases. Central tendency biases, it means that people usually take the neutral answer, the one in the middle. So sometimes you can see that to force people to not take the central answer, we only put like 4 items, like 2 negative and 2 positive. This is a way to make sure that they don't reply like in the center. Then we have social desirability bias, acquiescence bias. Social desirability also appears for people doing the experiments with you, because if a guy is coming to your experiment, they want to perform, because they will think that they are more desirable for you, like they are super cool, okay? So they will tend to be biased in the way they perform and interact with your robot. They will not say, I didn't like it. That's why at some point it's better if the author of the experiment goes away and the experiment is performed in a way where the participant doesn't interact with the experimenter. Otherwise, it will be very difficult to say your robot is really horrible. Nobody will say that. So it's better if you ask in a way that is separately. Okay, then we have a lot of type of metrics that are depending on the way we interact with the robot, task-specific, metrics for collaboration, AI-specific metrics that are related to the AI, but also to the way that the AI is interacting with the humans. Task performance usually is the time to complete the task, the number of errors that you do, but you can imagine many. And then there is one that is really interesting, especially for industry, is the robot attention demand. So when you have an autonomous robot that is performing the task and the human is kind of supervising, collaborating or supervising, but not actively doing the task, at some point in experiments and in industry, this is well documented in the literature, people, they just don't care about the robot anymore. And so they tend to be, to neglect and to overlook. And so they are getting distracted. And so this is very risky when you do the experiments. The opposite is that sometimes the robot is requested to ask the human to intervene. So this may seem bad, like I design a robot that is autonomous, but is keeping is asking continuously the human to intervene. And so you may think that this is bad, but actually, if they don't, in some cases it has been shown that the people are just they don't care, they're distracted, and this is very wrong, because they have to be attentive. So this is something that is, for example, in autonomous car, it has been documented a lot that the people overtrust the autonomous cars, and sometimes the car asks, okay, now you have to take the wheel because there is a problem, and people say, woof. They don't do it, and then there is an accident. Okay, so in industry, manufacturing, the same thing are documented. So sometimes the matrix is not as bad as it looks. That's why you need interpretation. And then you have team behavioral efficiency, cognitive effort. The fact that you're interacting with a robot or with an AI that is on the robot has an impact also on your cognitive behavior, on your attention, on your cognitive load. So this also has to be measured. Not always, but in some cases it's really important. And then you have AI-specific metrics, and in this case, it really depends on the way you use it. If it depends if you use it for, continuous learning, then you need to have some measure or metrics to measure how much the system is learning or adapting to the human, how many errors are done, if it is out of distribution or because it's encountering a behavior that has never been seen before, and so you have a particular situation. And then in these cases, because there is AI, there is also a lot of pressure to put metrics and measure that enable to measure if the human has understood the situation with the robot. Sometimes this is very difficult to do because it really depends on your experiment. An experiment where you do co-manipulation is not the same as navigation. And so the metrics will be different. But try to think about this as well, because sometimes you can ask the human, please, can you verbalize why you did that? But many times the humans cannot verbalize well and explain, they will be shy. So it's better to try to have some measures. Okay. Okay, and then you have the approbation of your protocol, the UNICE protocol that you design by the ethics committee. And so this really depends on the ethics committee. Usually the ethics committee has a big document, a template that you have to fill with many things. And this can include things about the fact that your staff that is doing the experiment is qualified, if they have a proper formation to interact with humans, the facilities, if you have planned sufficient time, if you are in a place where, for example, the experiment is hidden by the people. When we do the experiment in the cafeteria, we have to put the the curtains, we have to close the door because otherwise people are coming, oh, let me see your experiment. Yes, but this is an experiment, so the people that are there, the participants are in a sort of a vulnerable state. They don't want to be monkeys in the zoo for you to observe and say, oh, let's look at this guy, what he's doing. No. So we have to, let's say, close the area when it's possible. Otherwise, if we do the experiments in the wild, like in the corridor here, we cannot put curtains. This is a very sensitive type of experiment. So the ethics committee will ask you a lot of things because many people don't want to be, for example, filmed or images taken when they are in public spaces. And yes, and then a lot of, usually the ethics committee also wants to make sure that your experiment makes sense, that is really necessary, because if you mobilize people to do the experiments, they have to spend time with you, maybe your experiment is risky for safety for some reason. So they really want to know why do you need to do the experiment. So you have to provide some motivation, the benefits of the study, the risks. So learning how to draw the risk is also something that you have to learn, especially if you write European projects. But and then there are a lot of rules related to data, RGPD, and so on, blah, 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 consent forms, blah, blah, blah. This, unfortunately, there is not a unique recipe, because every ethics committee, depending on your nation, depending on your city, will change. The most standardized way, it's the one of the doctors. So in France, we have a single ethics committee for doctors, a national, and then you submit it to the national committee, and then this is dispatched to many hospitals. So they have more standardized way. But for robotics, we are in a sort of gray area, and even for AI, and I see a lot of papers that are not doing experiments where humans are validating, and they don't even submit ethics protocols. So at some point, I think this will arrive, because the European Commission is making regulation, adding regulations. So we have to be prepared to do that. Okay, so Dionys mentioned this yesterday. Doing a pilot study is not a bad idea when you do experiments. So the pilot study, typically you can also do it with your colleagues. You don't have to record the data, because sometimes the pilot study is a sort of mock experiment where you test your system, but you also test that the protocol of your experiment works, that is feasible, that doesn't take too much time. Usually, especially in papers, we are used to do a lot of benchmarks in simulation. In benchmarks in simulation, apart from consuming hours of GPU, water, electricity, and whatever, you can do infinite benchmarks, because your table can be, I don't know, 20 different algorithms, 20 different, scenarios, etc. The list can be very long, and you say, oh, look, I did a lot of ablation studies. But every line here is a condition. So if your experiment is done with humans, imagine a human doing an experiment with 20 conditions. Your experiment lasts how much? 1 week? It's not possible. So you have to be really careful. And so a pilot study is typically important to measure how long it takes for you to do the experiment. And if the experiment is too long, people will be tired and they will not perform. And so your data will be trash. And so you lose time, everybody's losing time. So the pilot study, when you have humans in the experiment, is really important to calibrate the number of conditions, how much time, etc. I know that sometimes the reviewers in your papers will say, oh, you should have tested this, etc. You can reply, okay, the experiment cannot be 5 hours, okay? And if the reviewer says something, you write to the editor, okay? And the editor hopefully understands, okay? So this is a very, very important part. Also, like, you don't have to care about statistics when you do a pilot study. It can be also 3-4 people. It's not important, but it really helps you to tune your experiments. And then when the pilot study says, okay, we can really do it, then you do the experiments. It depends if it's in a controlled environment or it's in the wild. In the wild, experiments are typically when we are in the corridors or in a museum, at the airport, okay? And when you do experiments in the wild, you cannot put thousands of cameras, you cannot put the sensors on the body of the humans. So we accept that we have degraded condition, we cannot access to all the measure. But these are the kind of experiment we will really test if your behavior works, if your AI model works. And then one thing that is often overlooked that I say to my students, use a calendar for planning the experiments, to have slots, okay? Because otherwise this will take you forever for you to do the experiments. And usually if you have a good calendar, you say, okay, I do the experiments like at 10, and then at 12 I do another participants, and tomorrow I do, I don't know, at 8, 9 and 10. Consider that when you give an appointment for an experiment, you need to also consider the time for welcoming the participant, explaining what you're going to do, put the sensor on, etc. So this you will see how much it takes from the pilot study, okay? So this is very important, but also remember to add some extra time, because sometimes participants are late. Sometimes if you are using many sensors or using a robot, the robot doesn't start. And so, I mean, if you only have considered like 1 hour for an experiment that lasts 50 minutes, and then you have to start again the robot, etc., at the end, the time that is requested will be longer. And so this is often overlooked. So never take too many meetings one after the other. Otherwise, you will cancel a lot of participants, and then participants are not coming back. If these are people from your lab, it's okay. But if you take participants from outside, like they have to take the bus, etc., to come to your place, so this is not nice to do. GDPR, so this is very important. So in Europe, we are bound by GDPR rules. So usually you should have a data protection officer in your institute. That is the person that is responsible for setting the rules for how to collect data, how to store data, etc. And you can find all the information in the website of the European Commission, but also your institute should provide the DPO. So this is a person with legal, let's say, it's a lawyer. It's a person that has a legal role, because he's responsible finally for the institute that all the data are collected in the good way. And because we have to comply with GDPR, the most critical for me constraints that we have is the fact that we have to give the possibility of participants to delete their data. So if you do an experiment with participant 1, participant 2, participant 3, 4, 5, etc., this is quite easy. If participant 5 says, delete my data, we delete the folder, that's it. But if you are collecting data like from a corridor, etc., or from the wild, there is no way to delete the data, because you don't even know who passed on that day. So here I give you the recipe that we found out here after 1 year of struggle with the legal stuff here and the DPO. We have a solution, which is that the people have to submit with the procedure to the DPO, so to the lawyers, their photo and the time where they pass to the next to the robot or where next to the camera, and then we have a software that is deleting the frames corresponding to the people. This is the solution we found. We try to investigate if there are better solutions, and this is the only thing that we found so far. I don't know what are the rules in your institute, but beware that this is something that will arrive to you. And typically, because lawyers don't understand anything about how AI models, data, computer vision works, this is something that you, as a PhD, you will have to do. And this is something that I don't like, but so far we don't have really an alternative, because there is no software, no standardized software to solve this problem. So we are still in the area where this is done ad hoc. Okay. And then finally, experiment is done. You have the data analysis and the discussion, so the interpretation of your results. I will not go into the details of this part because this is really specific. The only suggestion that I give you is to learn to do statistics. Once in a paper, I saw 3 repetitions and the person was doing an average over 3 data. this is unacceptable. There was a big discussion in robotics automation letters. I can say that this is thing, because you cannot do an average of 3 data and then claim whatever. So this is not possible. So learn how to do statistics and learn how to do statistical tests. You don't need to have 20,000 data to do a statistics, because there are tests that are designed also to test things with a different distribution, with parametric, non-parametric tests. So we don't have time to cover this, but this is something that you have to learn how to do. And second, learn how to interpret the data. Often we see students, they say, okay, these are my results, done. No, it's not done. You have to learn how to read a plot and learn how to read a table and see what the results are telling you. Sometimes, so an error that I see done a lot of time is the effect size. So for example, a lot of people say, okay, my super mega algorithm now is outperforming this state of the art of 0.1. Okay, good in this benchmark, now you win, bravo, gold medal. But okay, what is the impact when your model is used in the real world? Do we see a difference at the end? Because if no, then it's the same. Like, yes, you made better in a benchmark, but then it's the final experiment that tells us if there is an advantage or no in using your model. So often this thing of the effect size, I don't think it's really people really think about this. Sometimes they just stop at the data, at the tables. And this is something that you have to learn on the long run, because it will enable for you also to be better at judging the papers of other people. Not just taking the last paper that says we're the best. Okay, you have to learn, okay, you're the best, but doing what? And what is the impact of being the best? I mean, like, let's not just stop at numbers. Okay, so what is really important for the ethics committee? Because so the ethics committee is judging your protocol. They want to know what you do. They are very concerned about the data because this has legal implication for the institute. So the lawyers want to cover themselves. They want to be sure. But they will look at the safety. So the safety of your experiment. Is the experiment safe for the people doing the experiment? For example, if you have a human with a VLA and you're like feeding the humans, there is a bit of safety concern, I think. So maybe we have to be careful, like ensure that this experiment is really possible. And then usually they do something that is called ethics deliberation. So now we will see this too. So the safety, so they judge two things. First, safety for the environment. So these are so imagine if we say I want to have dancing in front of humans in my room, maybe there will be a bit of concerns. But also like the experiments, if humans are close, we cannot do experiments with humans without safety protection. Or if we do the experiment without the safety protection, the safe rails, then we have to be able to justify that we are not hurting people. Like what are the measures that we do to not hurt them? There is also safety for the robot. So this is a very old video from an experiment from a Japanese team, Japanese-Korean team, that they were experimenting robots in malls. So I think these were like 2010, 13, 12. So and so in the experiments, the robot was giving directions. It's very popular in the HRI literature. And then the children were violent and they kicked the robot. They actually destroyed the robot. So you can find some photos of the robot. The robot was completely destroyed because they were also bullying, really, it was very aggressive. And so this was, okay, there are a lot of behavioral implications about the behavior of humans against robots, also children against robots. But there are many experiments where we do this. And the problem is that, okay, this robot was kind of a mobile base without anything. But imagine if now we put a VLA on a humanoid, and the humanoid is, I don't know, patrolling the mall for a reason, because now we like it. Okay, so what are we going to do? There are also other concerns. So this is very extreme. Like if you do experiments with elderly people, with frail people, handicapped or I don't know, people that are sick, or there are many possible situations, we really need to be very careful when we do the experiments and making sure that the robots are like safe, etc. So this is a very popular example. So Paro, this is a baby seal robot. So this Paro robot has been widely used in the case of treating people with dementia. I don't know if you know what are people with dementia, but people with dementia can get very violent. They can have like a burst of very violent behavior against other people, against nurses, etc. And so this robot, if the person is violent, it can be thrown. It's like a toy. Then they found out that people like to cuddle and pet the robot. They think it's like a dog. So in dementia, often dogs are used. But so this is like, maybe more sanitary, I don't know. But apparently this is it's freely used a lot. Like I think it's the most sold robots for treating dementia. And other robots were used, but they were not as safe as this one and effective. So about safety, there are two things that you have to know. One is ISO norms. So these are the ISO norms are basically defining the rules on when the robots are deployed. And so if you read an ISO norm, which is a very long document with a lot of blah blah, sometimes you can find papers that resume the important points. Otherwise it's 200 pages and whatever. So the ISO norms, they tell you how to implement the safety measures, okay? Whereas you have the politicians in the European Commissions that do regulation, and so they will tell you what you can and cannot do. So the AI Act is not really telling you how to implement the safety measure, but what you can and cannot do. And so this is very big topic, so I will give you some pointers, and then depending on the research that you do, you have to follow, I mean, if you deploy in real world. So safety, there is a big galaxy of type of documents that are defining safety rules, ISO, TR, ESC, so there are many directives, etc. So I took this photo this image from a European project proposal that was about delivering some robots with navigation, like autonomous robots. It's a mess. If you read this deliverable, you can laugh basically, because the people say it's impossible to find a solution in this galaxy of many norms saying things that are like not really contradicting. Sometimes they are coherent, sometimes no. Okay, but there are many norms. So if one day you do a company and you sell a robot and the robot is used, or an AI, same is for AI because there is the equivalent also for AI models, you need to know this, because otherwise your product cannot be certified. Okay, so you cannot use it, you cannot sell it. And so this is important. There's a lot of people that are already producing controllers, method for the robot with these rules in mind. For example, people working in cobots usually implement some measure for, let's say, collaboration that is ISO compliant. But I mean, also these rules are continuously evolving. 10 years ago, we didn't have the AI part. So yes, there was a bit of machine learning, of adaptation, but who cares? Now the situation is a bit different. So they are being updated, okay? So the most important for you to know is the ISO 15066, which is the norm about safe collaborative operations. So this is the norm that was written to basically tell you how to implement the controllers of industrial manipulators in cobot mode, where the human workers are coming and interacting with the humans. And there are two main rules. I mean, there are many, but the most two important are the speed and separation monitoring and the power and force limiting. What does it mean? It means that if a human is approaching the robot, so you have to be able to measure in a factory floor the distance between the robot and the human, the robot has to slow down. And then there is the power and force limiting, because that basically is telling you how much force the robot can generate. And this is limiting when you getting hurt after an impact, because at some point maybe the human is there, puff, there is an impact, you don't want to crush the head of the poor participant, the poor worker. Okay, so there is another one that is important. There is an international standard for industrial robotics. So this was, so this is blah, blah, blah. This was recently updated, including more AI constraints. And so there is an interesting paper that I added here because it's a paper that is basically discussing what's the update about. And the interesting thing in this paper, they say, okay, they updated, but actually there is a lot of things that were updated in the wrong way. And there are a lot of limitations. For example, for humanoid robotics, I highlight this because this is something we know. The only constraint that they had, so the constraints are considering that the safety constraints are considered in the robot controlled in kinematics and with a fixed base, which means that the humanoid is not walking. And so it's also, yes, no, I'm late. I don't have more slides left. So for people that are doing humanoid robotics, I mean, you know that the first level of constraints that we had is when, oh, okay, this is very bad. It's when you have your QP controller, so your kinematic controller, because kinematic or dynamics, also the inverse dynamics, because you have your QP formulation or your MPC formulation, and you know that you have tasks with errors, with goals, but you also have a list of constraints. Equality constraints. Some are soft, so they can be violated, and some are strict and they cannot be violated. And like, yeah, this is like the safety level 0, okay? But this is the safety level 0 if the robot is alone. What if now the robot is interacting with a human? So first, if the robot is alone, okay, you have only the dynamic equation of the robot. If the robot is coupled with a human and you have a physical interaction, you are coupling two dynamic systems. So you cannot have constraints. You can have the constraints of the human, the constraints of the robot, but then you have the constraints of the couple because the couple is acting together. And so you have other constraints. These are not considered at all in the norm so far. So, yes, so the norm is okay-ish, but I mean, we have to think about the next 5-10 years. So these have to be put somewhere. And so also like it's very interesting to see that they also consider that now because of the perception loop, everything has to be planned with MPC control, not with just purely reactive control, because they say we have to be to provide proactive collision avoidance using sensor fusion and MPC to allow non-stop collaboration. So this means that the norm is already considering that there is a window of predicting what is going to be the future movement of the human, so that we can take this prediction and put it in the controller to anticipate, to stop safely. Because the robot, you know, when the robot stops, it doesn't stop immediately. There is like a little window of delay. Okay, and so more norms. So if you want, you can read the text. What is interesting for you to know is that the AI Act, you can read on the website, is not really providing you an answer on how to do things. It says a lot of things that you cannot do, but doesn't say really how to do things in a different way. So there is this pyramid that was introduced about the risks. And so I'm not going to discuss everything, but the unacceptable risk. So this is the things that we cannot do. So the Europe says we cannot do harmful AI-based manipulation and deception. So no manipulation using AI models. So we have to be very careful when we design an experiment to not give the illusion that the robot is doing something, because this is a form of manipulation. And so now, because we are going to discuss with the robots, with using models that we don't know how they are trained and what are the hidden rewards maybe for the post-training or whatever. So we have to be kind of careful about that. We cannot do social scoring. We cannot do emotion recognition in workplaces. Imagine for us for doing the experiments here, because we are in a workplace where we do, if you are even in an airport, you are in a workplace. So we cannot recognize emotions, because this could be used potentially to, you know, control the workers or to blackmail the workers who, I don't know, to do something bad. Real-time biometric identification only for law purposes. So face recognition is very risky. Everything that is research about personalization that is including face recognition is very risky. And last, ethics, so this is important for you. So there is, if you want to have something to start, when you submit a European project, you have an ethics issues form that for the moment is very simple. You have to say if you do some type of experiments or no, but this triggers particular question, like, are you doing experiment with human? Yes, you declare. Okay, now I want to know what are you going to do with these humans in your experiments, with the data and so on. So when you do an ethics deliberation on your own experiment, because you can do it on your own experiment, basically this is an exercise where you have to stop and ask questions. So, and the questions are mostly, why am I doing that? Why am I doing this? Do we need that? Do we need a robot that is serving coffee in the cafeteria? Do I need a VLA to control my robot, or I can do maybe a traditional controller? This is a legit question. Also, the ethics committee will ask that. What happens if we succeed? Is it something that can be reused like in dual use mode? Is it something that's going to change? It's going to, I don't know, change the way we work? Or so what happens if we succeed can have a positive outcome or a negative outcome, but also a positive. Actually, we try to do things to have positive outcome, like I want to work better, I want to improve working condition. So the ethics committee will look at many things, and these are the most important. Inclusion criteria, so who is participating to your experiments, beside the pilot study, the paper that you do, but what is the people that are going to use your method? How are you recruiting participants? Are you using any form of coercion? For example, if you are a supervisor and you're obliging students to do an experiment, and maybe you say, if you don't do experiments, I don't give you a PhD. This is a form of coercion. Like sometimes we say, please help your colleague to do an experiment. It's not the same. And like, in a lab, I mean, all the students are collaborating and working together because there's sort of a fellowship of the ring mode. But this is different if it is your employer that is asking you to do something, obliging you, like telling you that if you don't do it, there will be consequences. So if, for example, right now we do experiments in the hospital, and so we have to do experiments with the workers of the hospital. And we have somebody that, we have to ask the authorization to the head of the workers. So we are in a situation that is very delicate, because there may be, so we have to be careful that there is no way, that it's very clear that there is no obligation and they don't have any benefit in terms of monetary compensation if they help us in doing the experiment. They don't have a negative consequence if they don't help us. So the ethics committee will ask us, for example, how do you communicate the experiments to the participant? Can you give us the text, for example, the text that you write, so that we want to make sure that there is no coercion, there is no particular benefit or advantage or risk. The benefit and risk, this is also something that you have to ask, like in an experiment. Compensation, so now, before it was very common that people were receiving a sort of monetary reward, symbolic, not that they were really paid with a salary, but they had Amazon card, 10 euro, or something symbolic, but it was for the gratification. It was the French term gratification. Elisabetta can confirm. But now the ethics committee says, okay, this is an advantage in money. And so it could be an incitation for them to do a lot of experiments and perform. So you call them back to do other experiments. And so this is not good. It's a source of bias. So actually now they are forbidden to pay. So we always give, some biscuits, a notebook or something, but this is very bad. And so, yes, a fun. Yes, okay, little exercise, you can do it after, and we can discuss tonight. It's the one that I sent you online, that I sent you via email last night. So consider the case of the robot of 1X that is deployed in the home. So read the text that I send you. It takes 5 minutes. So you can find all the information online. The robot is in the home, And we have to collect the data from the home to train better models, because the model that they have is not good. Okay, we agree. So the question that we have to ask, now you're the ethics committee, you have to give me a deliberation. Do we approve the experiments of 1X to collect data from the people that are at home, with the kids, with the grandpa, with whatever? Do you approve the experiments? Do you have concerns, like moral concerns? Is something that it goes against your principle? It's something that for you goes against the principles, like the moral beliefs of our society? How do you value the privacy in this case? How do you evaluate the risks and the benefits? So this is the kind of question that you have to ask. And so this is a good exercise because we are many and not everybody has the same beliefs and the same priorities in the moral values. So yes, I would like to discuss this tonight. Yes, and you will give me the answer or at the coffee break. Yeah, and we finish this.